This video is meant to be a quick overview of what confidence intervals are and how you're going to be receiving or trying to come up with a range of values where the true population proportion could lie. So, for example, you need some information from the statistic. We have 0.25 and 0.05 is our standard deviation from our statistic. And we're looking for a 95% confidence interval. So remember, for this curve, this is 95%, and this is supposed to be centered around and you can center it around your statistic. And 2 standard deviations above is your 95% confidence interval, combined with 2 standard deviations below. So we could kind of mentally figure this one out where 0.05 is 1 standard deviation up and then another standard deviation up. This would bring us to about 0.35. If we're looking for standard deviations below, we would end up with maybe 0.2 and 0.15. So this is all our confidence interval. The answer really that we're looking for is a range of values, meaning from 0.15 to 0.35. So we put them in numerical order, smallest to largest, is where the true population could lie, proportion could lie. Let's go through how we got this number. All right, what we did was we took our statistic, we took that answer, and we added 2 standard deviations to it. Now, if we look at this chart, that gave us 0.35. If we look at this chart below, if we had to do a standard or confidence interval of something other than something we've already know, like 68, 95%, or 99.7, we need to use this chart to be able to figure it out. So if we look at where on this chart would actually help us, if you think about it, this chart is going to be giving us this whole standard curve, and below it gives us all of this. So when we think about what would be in this spot, that would be where 97.5% lies. Because if there's 95% in the middle, there's 2.5% below and 2.5% above. So if we look at this chart, 975 is right about here, and it correlates to the number 1.96. So we can calculate this with 2 because that's what we've been doing, or if we're using the chart, we can use 1.96. They're all going to be very close to each other. Following through with what we were doing before, 2 whole standard deviations below gave us this number. And that's the range that we're looking for. So let's look at an example like this lower one, where it's 90% confidence interval. So when we think about this, we don't have that number memorized. We don't know how many standard deviations above the mean it is. We know the 0.25 would go here, but we don't have how many it's not quite 2 standard deviations because that would be 95%. So we have to use the chart to be able to figure out what this value, we call it the critical value. We need to figure out what that critical value is to be able to calculate how many standard deviations above. So if we're thinking about that critical value, we basically need to look in the chart for this number, everything below that 5%. So I'm thinking we've got 5% here and 90% in the middle. We're looking for what number goes along with in our z-score table with 0.95. So 0.95 is actually right here between 0.9495. Actually, it's perfectly in between 0.9495 and 0.9505. So this 1.64 or 1.65. Either one would actually be accurate, and that would be considered our critical value. I'm going to use maybe 0.645 because that would be right in between those two. But you can actually pick one or the other. We're looking for a close value, but it doesn't have to be identical. Let's think about what we did above for our formula. We took this statistic and we took this critical value and times it by the standard deviation of the statistic. So we're going to do the same thing for this question. We're going to take our statistic and we added it and we subtracted it, so we can kind of do it as a formula written out in one shot. We don't want two standard deviations above. It's more than one standard deviation. We found it was about 1.645 standard deviations away from the mean. And we're coming up with that range. So we do have to do each one of these independently, like adding 0.645 times the standard deviation, which gives us, and we also want to subtract that many standard deviations below the statistic. And our goal is really to come up with the interval. For where we are 90% confident that the true proportion would lie between these two numbers. So if you look above, our interval compared to the other one up here, our interval is a little bit smaller because we're giving a smaller confidence interval and we have smaller confidence in it. There'll be more examples to come, but I wanted to give you a little overview of how we come up with the critical value and what the basics of a confidence interval